Hello everyone. So let's start the new topic for today. It is annuity. Now what is annuity? Annuity is a multiple cash flow series. It's a multiple cash flow series. So there will be more than one cash flow. Cash flow should be constant, that is the value of cash flow will be constant irrespective of the number of cash flows. And then there will be a constant time gap between two consecutive cash flow. It can be annual, it can be semi-annual, it can be quarterly. We will take the example of annual. If the question comes for semi-annual, if the problem comes for semi-annual, what we are going to do? We are going to half the rate and we will increase the number of periods from year. If 4 years is the time, then we will make it 8 cash flows. And it's a limited series. Limited series means there is an end point. Starting point and the end point. It is not extending till infinite. If it is extending till infinite, it becomes perpetual series, perpetuity. So now today we are talking about annuity. So there are 4 characteristics, all should be satisfied. Number 1, it is a multi-cash flow series. Number 2, constant cash flows should be there. Constant time gap between 2 consecutive cash flow, and last one is, it is a limited series. Now next, what are the type of annuity series can be there? There are 2 type of annuity series. Number 1 is called as ordinary or regular annuity, and second is called as annuity due. Now we can take the example of rent. If we have taken a house on rent, we are paying rent at the start of every month. That is an annuity due. And let's say we have taken a home loan and every month end we are paying EMI. That is a regular annuity. So what are the 2 type of annuity? Both annuities will satisfy the above 4 condition, but there will be additional 1 condition, 5th condition. If the cash flows are arising, so we have a 4-year series, T0 to T4, and there are 4 cash flows, constant cash flows of 100 rupees. And if the cash flows are arising or they are placed, indexed at end of each period, end of every year, end of every semi-annual, end of every quarter, then the series is called as ordinary annuity. So we have year 1 end. What is year 1 end? It is T1, end of year 1, end of year 2, end of year 3, and end of year 4. At every year's end, we are having a cash flow of 100 rupees. This type of series, 100 rupees is the constant amount, and it is not a single amount, it's multiple cash flow which are placed on this particular time series. So it is a annuity, regular annuity. Next, if the cash flows are arising, indexed or placed at beginning of each period, beginning of year 1, T0 is beginning of year 1. T1 is not beginning of year 1, it is end of year 1. So it is beginning of year 2, beginning of year 3, and this is beginning of year 4. Of course, if you have taken a house on rent, so you will be paying only 4 rent, 4 times you are going to pay rent. So it will be at the start of first year, start of second year, start of third year, and start of fourth year. That is T0, 1, 2, 3, that's it. You are not going to pay 5th rent, that is on T4, because you are not using the house for 5th year. So when the cash flows are indexed or placed at the beginning of each year, this type of annuity is called as annuity due. So now why we are studying this type of mathematics? Because this particular mathematics will be used in corporate finance in case of calculation of loan schedules, that is your EMIs, and or comparing the different type of loan schedules, and sinking fund investment. If you have a target maturity of XYZ amount which is placed at some future point of time, how much you need to save every year to get in maturity equivalent to that requirement, whatever you are having at that future point of time. Let's say if you have a son and you are planning for his higher education, for that you will be requiring 1 CR at the end of 10th year. So how much you should be investing each year so that you can accumulate that 1 CR at the end of 10th year. That is the concept of sinking fund. We will take the example, practical example in the next part, but let's understand the mathematics part and what are the symbols we will be using and how we are going to calculate the values with the financial calculator and if we are using simple calculator. So let's go for the first type of calculation. We will be doing 4 calculation of annuities. Annuities, 2 type of annuity, regular annuity and annuity due. For regular annuity or ordinary annuity, I'll say ordinary annuity, we will be calculating future value, future value and present value. Now when I say future value, of course the basic concept of compounding will work here. A equals to P 1 plus I to the power T. When I am saying present value, of course the basic concept of discounting will work here. That is P equals to A multiplied by 1 upon 1 plus I to the power T. And same thing for future value of annuity due, we will be using compounding, and for present value we will be using discounting. So let's start with these 4 mathematics, and in the next part we will discuss some cash flows related to loan schedule and the sinking fund investment. So first, future value of ordinary annuity. So now 5 conditions should be satisfied. Number 1, it's a limited series. We have a limited series T0 to T4. Number 2, constant cash flows. We have 100 rupees constant cash flow. Number 3, multiple cash flow. We have 4 times 100 placed at different point of time. Constant time gap. The time gap is yearly. Annual, let's assume it's a yearly series. And next, the 5th assumption is it is an ordinary annuity. So it means all the cash flows will be placed at the end of each period. So I have placed 100 rupees at T1, end of year 1. It's not beginning of year 1. T2, T3 and T4. The gap between T1, T2, T3 is not important. It's just a representation on the series, on a line segment. Now what you want to find out? So we have to read this future value of annuity due in a reverse order. First of all, it is an annuity. Which type of annuity? Ordinary annuity. So annuity means 4 conditions satisfied. Ordinary annuity means 5th, end of the period condition should be satisfied. And now we want to calculate future value. Future value will be standing at what point of time? T0 or T4? It will be standing at T4. So I have placed question mark at T4, future value. So it means we want to move all 100 rupees which are placed from T1 to T4 to a single point of time, that is T4. We want to find out that this 100 rupees which we are investing, which we are paying at the end of each year for 4 years, what will be the consolidated maturity value at the end of the 4th year? What will be the consolidated or the maturity value at the end of 4 years? So it means if we are investing 100 rupees, interest will be loaded in that amount. So loading, the technique of loading interest is called as compounding. So we will be compounding at the rate of 10%, the favorite rate of interest, that is 10%. So for compounding, what is the basic equation? For compounding, basic equation is A equals to P multiplied by 1 plus I to the power T. A equals to P 1 plus I to the power T. But this equation is applicable on an individual cash flow, not multiple cash flow. So what we are going to do is, we are going to apply this equation on each of the 100 rupees. So first 100 rupees is placed at T1. We need to bring it to T4. So for how many periods we are going to get interest? Not 4. It will be 3 only. Because if you are investing at the end of the first year, and if you are redeeming it at, or if you are withdrawing it at the T4, that is at the end of the 4th year, bank or the mutual fund or your investment will give you return for only 3 years, not 4 years. So what I have done, I am shifting all 100 rupees to T4. So first 100 rupees which is standing at T0, shifting to T4, so 1.10 multiply, compounding. The 1 plus I will be in the numerator to the power 3. The second 100 is placed at T2 100 with a summation sign plus 100 multiplied by 1.10 in the numerator and with the power 2, because from T2 to T4 only 2 years interest or returns will be available. Then 100 into 1.10 powers 1, and then 100 into 1.10 power 0. Anything power 0 is 1. So, because you have invested at the end of 4th year and you are withdrawing also, nothing will be given as a return, only your principal will be returned back. So, 100 into 1 will become 100 again. So, now what I can do, I can take common, 100 rupees common. So, what I am getting is 1.10 power 3, power 2, power 1 and power 0 will become 1. So, this mathematical equation is written in the different format in finance. The format which we use is FV equals to CF multiplied by FV AF I percent comma N. Mind it, in this case, in the compounding case, we were using FV equals to PV, not CF, multiplied by FV IF, not AF, I percent comma T, not N. So, there is a difference in the symbol of compounding and future value of a single amount and future value of an annuity. So, in place of PV, we are using CF, cash flow, because it is not a single present value. There are multiple cash flows. Number 2, in the third alphabet in the symbol, FVIF denote there is only single cash flow. FVAF denote there are multiple cash flow. It's an annuity. And then rather than using T, we are using N. N represent number of cash flows. T represent number of period. Why I am not using T? Because number of period for which 100 will be compounded is different for each 100. For first 100 which is standing at T1, it is compounded for 3 years. The second 100 which is standing at T2, it is compounded for 2 years. The third 100 which is standing at T3, it is compounded only for 1 year. And the fourth 100 which is standing at T4, there is no compounding at all. So, number of period is different. So, we are not using T, we are using N. N represents your number of cash flow. For how many cash flows will be transferred to the future point of time. So, if I write this equation, it will become FV equals to, if this mathematical equation will convert into FV equals to 100 into FVAF 10% comma 4 cash flow. What is the full form of future value annuity factor? FVAF is future value annuity factor at the rate I% for n number of cash flow, and each cash flow will have a different power. Each cash flow will have a different power, and power will depend how many periods the cash flow is moving forward. So, how to calculate this? Very simple. In case of financial calculator, it is very simple. In case of simple calculation, you have to learn the procedure. Complete working procedure needs to be, you have to remember that procedure. And because this is just a 4 years cash flow, if there are 10 cash flows, then the procedure will take time also. But it's a simple procedure, it's not that difficult. I will do procedure in both the calculators. Let's see financial calculator. Again, this financial calculator. Original financial calculator will have this type of display. It can be 2 decimal. I will guide you to, I will take this, how to convert this decimal number of digits after decimal from 2 to 4 or 4 to 2. I will take that in the next video. But let's see, let's take the normal calculation for how to calculate future value. First of all, this calculator is already set on the ordinary annuity mode. Ordinary annuity mode. If you want to convert it into annuity due mode, you have to process something. And if it is in the annuity due mode, to convert it back to ordinary annuity, you have to do some process. What will be the difference? The difference will come in the display. Right now on the display, it's only 0.000. If you want to convert it, right now its default is ordinary annuity. If you want to convert it into ordinary annuity due, you have to activate second function. Then in the third row, fourth key, BGN, beginning, press BGN. On display it is end set. It's saying that at present your cash flows are at the end of the period. Go for again second. And now press the second key in the first row, that is set. The calculator mode got changed from ordinary to annuity due. 4 symbols. Second, BGN, second, set. Now what is displayed? Now let's press the clear work, that last row, first key. Now there is a BGN symbol coming on the top of the display. This shows that the calculator is running on the annuity due mode. Since we are doing ordinary annuity, let's convert it back. The process is same process. Again, activate second, activate BGN, the fourth key in the third row. It says at present it is at the BGN mode. Again, activate second and press set. So it will convert into end mode. Second BGN, second set. 4 keys will be pressed, 4 keys will be used in the sequence and to convert from ordinary to annuity due or annuity due to ordinary annuity. So right now it's set on ordinary annuity mode because there is no BGN coming on the display. Now what we are going to do? We have to calculate future value. So future value key will be used at the last. First we have to give the values of 4 keys, that third row keys. How many cash flows? That n represent your number of cash flows now. N, 4 and then n. At what rate you need to compound? 10 in number form, not percentage or decimal form. IY, it will automatically convert into percent form. There is no present value. On T0 there is no cash flow. 0 PV. PMT shows your cash flow value of annuity. So 100 PMT. Now compute future value. It gives you 464.10. This is the value. Now how to use in simple calculator? Simple calculator you have to process. This complete mathematical equation you have to calculate in simple calculator. And simple calculator helps you in some form that it can calculate the values from lower power to higher power. Let's see. Simple calculator. So how to calculate this bracket now? First, press 1. Transfer that to m plus 1 m plus. So your first number 1, the right hand side number 1 is added in the memory, which the default value of memory is 0. Now press 1.1 m plus. On display it is showing 1.1, but already in 1 that 1.1 is already added in the memory. So now in the memory you have 2.1. Now you need square, multiply. Do not press 1.1, just press equals to. It will automatically make it square. M plus. Now you need not to multiply because otherwise square will become square, so power will become 4. You need power 3. Again press only equals to. M plus. Now all 4 digits are already added in the memory. Recall the memory, that is MRC 4.641, 4.641. Sorry, not this one. This is 4.641 multiplied by 100 gives you 464.10, the same value which we have got from the financial calculator. But in case of simple calculator, you need to learn this procedure. Otherwise, you will end up doing individual calculation and then writing it that first you will calculate how to 1.3, 1.1 multiply equals to this value. Then you will say, write it, then you will calculate 1.1 multiply equals to 1.21, then 1.1 and then 1, and then you have to manually add each and every number. Right now we have only 4 digits. If there are 20 digits, it will take a lot of time and there are chances of error also. So that is why we need to learn this procedure so that less keys will be used and we can quickly calculate the value. In case of financial calculator, of course, things can be done very quickly. They have direct functions for these future value and present value calculation. So I hope future value of ordinary annuity is done. Let's go for future value of annuity due. Future value of annuity due. Now, same calculation. The only difference is cash flow will be placed at annuity due. So it is a multi-cash flow series, but the cash flows are standing at beginning of each period. If cash flows are standing at beginning of each period, so 100 will be placed at the beginning of first year, that is T0. Beginning of second year, that is T1. Beginning of third year, that is T2. And beginning of fourth year, that is T3. But you need to calculate future value. So question mark will be placed at T4. So again, time series is done. So calculation, you need to transfer 100, you need to move forward. So for forward, you have to do compounding at the rate of 10%. So first 100, which is standing at T0, how many steps you have to move forward? 4 steps, because at the start of first year till end of fourth year, you will get interest for 4 periods. That is why 100 multiplied by 1.1. 1.1 is a numerator. You are doing compounding. You are loading interest. Power 4. Second 100 standing at T1. You are moving forward to T4. Power 3, power 2, power 1. There is a difference. Here the power was 3210. Now the power convert to 4321 because there is additional 1 year compounding, because all cash flows are standing 1 year ahead of your ordinary annuity. So now the calculation is this. There is no symbol for annuity due. We have only symbol for ordinary annuity. So what we are going to do, we are going to twist that symbol for annuity due. There is no symbol in the corporate finance for annuity dues. So what we are going to do, we will take 1.10 common from this bracket. Move out. Again it will become 100 into 1.10 power cube, 1.10 square, 1.1 plus 1 whole multiplied by 1.1 power 1. So this bracket with 4 digits is exactly the same bracket which we were using in the ordinary annuity. Just we have taken 1.1 common out. So for this bracket, we have this symbol. So if we have this symbol, we will use it again. And with a 1.1 multiplied after calculation of FVAF. So in general, it is FV equals to CF, cash flow, not present value, multiple cash flow is there, into FVAF, annuity factor, I% comma N, 4 cash flows. These are representing 4 cash flow multiplied by 1 common factor, that is 1 plus I to the power 1. How to calculate it? Again, this is a different type of annuity. This is a different type of annuity. So now we need to convert. Right now my calculator is set at ordinary annuity mode. There is no BGN at the beginning of on the top of the display. You have to convert it into or annuity due. Second BGN, second set. With this BGN is appearing. Now clear work, you will say get BGN on the top of the display. Now same procedure. The remaining procedure is exact same. There is no present value. That 100 which is standing at T0 is part of annuity. No additional amount is paid at T0. 100 as PMT, your annuity amount. 10 is your interest rate. 4 are the number of cash flow. What is the future value? Compute future value. CPT future value. You will get 510. Because you are getting 1 year additional interest because you are investing at the beginning of each period. So this 464, if you are investing at the end of period, become 510 if you are investing at the beginning of the period. Next, if you are using simple calculator, this complete calculation will be done in the simple calculator. How to do it? 1.1 M plus, the first goes into the memory. First we need to remove everything from memory. You have to press MRC consecutively, then there should not be any symbol of memory on the display. M symbol should not be there. If M symbol is not there, it means your memory is clear. 1.1 M plus. Multiply equals to, it will become 1.21 M plus. Now do not press multiply, otherwise it will make square. So it will become power 4. Only equals to, it will automatically make it cube. M plus equals to power 4 M plus and then MRC, you get 1.5051. 1.5051. So this is 1.5051 multiplied by 100 gives you 510.51. Same calculation, but same type of numbers, same equation we are calculating, but different steps are used. So I hope everyone understood this calculation, how to convert from ordinary to annuity due mode in the financial calculator, and how to convert this mathematical equation into the the equation format of finance, because in books or in your question you will get this type of format. So let's go for the next two part, that is present value of ordinary annuity. Present value of ordinary annuity, or it is an ordinary annuity. So 5 conditions are satisfied, cash flows are standing at the end of the period. But now you want to calculate present value, and present value will stand at T0. So question mark is at T0, and we say PV equals to 0. Earlier we were saying future value equals to question mark. Now it is PV equals to question mark. You need to move backward. Moving backward means discounting. You have to extract interest at the rate of 10%. And what is the basic formula for discounting? P equals to A multiplied by 1 upon the 1.10 will be in the denominator, or we were writing PV equals to FV multiplied by PV IF I% comma T. So moving backward, how many steps you need to move backward? The first 100 is standing at T1 and you need to move it back to T0. So you need to extract interest for one period. So what I have done, 100 multiplied by 1 divided by 1.10 power 1. The second 100 is standing at T2. 2 step backward, power 2 with a plus sign, because we will be adding all numbers. Third 100 standing at T3, moving to T0, 3 step backward. Fourth 100, 4 steps backward. Taking 100 common out, we got power 1, 2, 3 and 4 in the denominator. In case of future value, 1.10 were in the numerator. In present value, 1.10 will come in the denominator. Power will depend on how many steps you are moving forward or how many steps you are moving backward. Now, how to calculate this equation of present value and how to present in the corporate finance. In corporate finance, again for ordinary annuity, we have a symbol. PV is equals to CF, not future value, because CF represent multiple cash flow. PVAF, it's annuity factor, it's not interest factor. I% comma N, not T, because T will be different for each 100. The 100 which standing at T1 will move backward once only. 100 standing at T2 will move backward 2 steps. From T3 to T0, 3 steps, and T4 to T0, 4 steps. So steps are not fixed for all 100 values of 100 which are because they are standing at different point of time. So what is the full form? PVAF I% comma N is present value annuity factor at I% for N number of cash flow. Earlier it was T number of periods. How to calculate it? Again, it is for financial calculator. Right now my calculator is set at with a BGN coming on the display. So it is set at annuity due mode. We have to convert it into ordinary annuity. Second BGN, second set. Now BGN gone from the display, so it's ordinary annuity. What do you have to calculate? Present value. So present value PV symbol will be used at the last. First you have to fill the values of 4 different symbols. N, 4 number of cash flows. IY, 10. PMT, 100. Future value, nothing, 0. That 100 which is standing at T4 is already included in PMT. So no future value other than that 100. CPT PV, you got 316.98. So complete this equation is done using these 4-5 symbols. In simple calculator, you have to calculate each and every value, but still there is a trick. You can do it easily. You need not to calculate each and every individual value and then manually add each and. Your calculator can process from lower power to higher power, that is 1 to 4 can be done in a sequence. How to do it? Using the memory. So let's start the simple calculator. So we need to process this 1 upon 1.10 power, not 4, power 1. First calculate the lower power. Memory should be clear. 1 divided by 1.1, on display you got 0.909, add it in the m plus. Do not press anything, just press equals to, it will automatically become square in the denominator, m plus. Equals to, it will become cube in the denominator, m plus. Equals to m plus. 4 already gone in the memory, we need 4 numbers only MRC 3.169. These are your keys. So if you are using simple calculator, you should be aware about this procedure working. Done? Both have 316.98, 316.98. Let's move to the last part. That is your present value of annuity due. Again annuity due, 5 condition, but cash flows are standing at beginning. Standing at T0 also, and you are calculating value of at T0 also, including this 100. So you are calculating value of present value, relative present value of all 4 amount, 100 rupees standing from T0 to T3. So bringing backward, you need to do discounting at the rate 10%. Sir, first 100 is already standing at T0 and we want to calculate relative value at T0, it will be same. 100 is equals to 100 for today. Yes, 100 into 1 upon 1.10 power 0. Anything power 0 is 1, 1 upon 1 become 1. But second 100 standing at T1, you are bringing it backward one step. So power 1, 2 and 3. Earlier in case of ordinary annuity, power was 1, 2, 3, 4 because cash flows were standing at the end of the period. Right now cash flows are standing at the beginning of the period. Why this mathematics we are discussing? Because this will be used in finance for valuation, for taking decisions also. Let's take 100 common out. We got 1 upon 1.10 power 0, which will become 1. So this got converted into 1. 1. Plus. Remaining 3 I have covered under a curly bracket. Power 1, power 2 and power 3. And this power 1, 2, 3 is same as power 1, 2, 3 here. If it is power 4, we have used 4 in n. Now since there are only 3 cash flows, we can use PVAF 10%, 3. Again for annuity due, there is no other different symbol. So we have to twist the ordinary annuity symbol. So how to write in the finance? We are writing PV. CF, not PV equals to future value into PVIF I%, T. In place of this single, because this is used for single cash flow. We are having 4 cash flows. PV equals to CF 1 plus, it shows that the first cash flow is standing at T0 itself. So there is no discounting, no extraction of interest. PVAF I% for remaining number of cash flow. If there are 4 period, then the cash flow will be 3 because only 3 needs to be brought back to T0. So how to calculate it? On the financial calculator, easy. Let's take the first financial calculator. Now my calculator is at the ordinary annuity mode. First I have to convert that into annuity due. Second set, second BGN, second set. On display I have got BGN. Same procedure, 0 in future value, 100 in PMT, 10 in IY, 4 number of cash flow, CPT, PV, you got 348. Complete equation in 5 keys. In case of simple calculator, now you have to do some working. You need to learn the procedure. You have to practice for these procedures. How to calculate it? Again from small power to higher power. That is from 0 to 1 to 3 and will be calculated. How to do it? First of all, memory should be clear. 1 because the first 1 upon 1.10 power 0 is 1. 1 m plus. Divide by 1.1 equals to m plus 0.909. No divide, no 1.10, directly press equals to, it will automatically make denominator square, M plus, equals to M plus MRC. You got 3.486, which will be multiplied by 100, it will become 3.348. There is alternate way of writing this equation. You can take again 1.10 common in the numerator, and then the power will become 1234 in the denominator. So many authors, they use this alternate also. We will be using this alternate, the first alternate in our class. So with this, let's close this concept. In the next part, I will discuss some use of these annuities. So please do practice. For practice, I can give you a question, that is, calculate present value of ordinary annuity at the rate 12% for 6 cash flows. Make it future value also for same rate. Make it same for annuity due and future value of AD at the rate this. So do practice for these 4 things. I will give you the values, answers. First, let's take ordinary annuity, present value 12%, 6 cash flows, 100 rupees, assume 100 rupees. We want to calculate present value. So present value will be 411.14. We want to calculate future value, will be 811.51. I'll recheck it. 12, 6, 100, 0, compute present value 411, future value 118. Next, second set, second beginning, it is 12, 6, 100, 0, present value is 460.47 and future value is 908.90. Please do practice on both. If you are using financial calculator, then do it on financial, and if you are using it on simple, please do it on simple calculator. Done. Thank you so much.